If you're wondering what are decision trees and doesn't know much about it, then this video is going to be useful for you. Folks, Nitin here, and this is the AI University channel. In this video, we are going to learn about decision trees. That is, how exactly it works. I'm going to explain it in detail and by taking an example so that you would be able to understand the concept clearly. This is very important concept if you want to build a model which is not only fast but also easy to interpret. So watch this video till the end to get the complete details. If you are new here, then consider subscribing to this channel, or if you have already subscribed, then click on the bell icon to receive the notifications about hottest technologies of 21st century. GitHub link for all the required Jupyter notebooks is given in the description section as well as at the end of the video. Please don't forget to like and share as well. So what is decision tree? Well, a decision tree is a supervised machine learning model which is used to predict a target variable by learning decision rules from associated features. Using decision trees, we can make decisions by using a flowchart like tree structure, just like shown here. In decision trees, we generally break down our data by making a decision based on series of yes/no questions. This path from root to leaf is called as classification rule. Now, each of these internal nodes represents an attribute or feature on which a particular decision needs to be taken. For example, consider an attribute called weather condition from weather dataset which has options as rainy, cloudy and sunny. Each of these leaf nodes represents a label which is nothing but final decision taken after the computation of all the attributes. Decision tree algorithms are sometimes referred as classification and regression trees because these are suited very well for solving problems related to both regression as well as classification. In case of decision tree classification, we predict the categorical target variable. So before moving forward, let me tell you quickly about two kinds of nodes which are associated with decision trees. There are a lot of other such concepts associated with decision trees, and if you want to get details about those concepts as well, then you can watch this decision tree regression related video. So if I talk about a decision node is something from where you see branches coming out just like shown here. So if you split this node into two or more subnodes, then this node will be referred as decision node. The significance of decision node is that it is like a test where we check any specific condition. The result of this test is in the form of yes and no or high and low. Now this test is actually performed on a specific feature or variable in a given data set. For example, this data set has these features or variables, and test is actually performed on these variables only in order to take a decision of whether the value of this test is going to be yes or no. Next concept is terminal or leaf node. So the bottom level node which can't be divided or split further are called terminal or leaf node. This leaf node contains actual class value, that is unknown data points class is determined or assigned at these leaf nodes only. There are various decision tree algorithms or ways using which we can do a split of training data or data set. The most popular ones are ID3, C4.5, CADE, Mars. Please note that explanation of how the split happens using these algorithms is out of scope of this video, and I will create maybe a separate video to explain each one of them. For now, just keep in mind how and where these splits should happen can be handled by algorithm itself. So now let me take an example and show the entire process in detail. Here we want to predict the value of target variable called lone decision, whose values are accepted or rejected. So you can very well see that these are in binary form, accepted or rejected. So accepted can be treated as 1 and rejected can be treated as 0. And these are also categorical in nature. I will be showing details around a split happening on dataset on left hand side and the corresponding decision tree getting created based on that split at the right hand side. So let's consider we have this hypothetical data shown in terms of black and orange dots, and it has two independent variables, namely income and credit score. And we also have a one dependent variable called lone decision. So lone decision is also the variable we want to predict. So basically we have three-dimensional data, but for the sake of simplicity, I'm not showing the lone decision, which can be represented on the x-axis for now. If you are wondering how it can be represented in three-dimensional space, then this is how it will look like. So when you run the decision tree algorithm on this data, then it will divide or split the entire data into segments. Now, how algorithm knows about where to split the data? Well, there is some high level mathematics which is utilized to do these splits, and as I mentioned earlier, there are certain algorithms which can be utilized to do these splits, and I'm going to explain the mathematical part, or the algorithmic part in the later videos. For now, just remember that algorithm tries to find out the optimal splits which are going to maximize the number of different points in each of the leaf. So let's say first split happens at income is equals to 120,000. If the income is greater than 120,000, then we will have one branch of the tree which is depicted by yes. And if the income is less than 120,000, then we will have another branch of the tree which is depicted by no, thereby dividing the data into two parts. This segment here represents a terminal node, and it depicts that if the person has income greater than equals to 120,000, then his loan would be approved. All the observations or data points represented in black are approved cases. Let's move on to the right hand side. So from decision tree perspective, the split or decision will look something like this. If the income is greater than 120,000, then the value of target variable loan decision would be approved. If the income is less than 120,000, then we will check the next condition. Now the next split, which is split 2, happens for independent variable credit score to the bottom of split 1 and at value 600, dividing the data into two parts. So observations to the left of the split 2 will represent credit score less than 600, and observations to the right of the split 2 will represent credit score greater than equals to 600. Let's move on to the right hand side. So from decision tree perspective, the split 2 happened at 600 and only to the bottom of the split 1, so the corresponding decision tree branch will look something like this. So we were concerned with income less than 120,000, so we are falling in this branch. Then our split 2 happened at credit score equals to 600. So if the credit score is greater than equals to 600, then the value of target variable loan decision would be approved. If the credit score is less than 600, then the value of target variable loan decision would be rejected. So these node leaves or terminal represent the predicted class. So whenever you encounter a new data point for which you want to predict whether the loan is going to be accepted or rejected, then it would be classified in this way using decision tree. Please note that these leaf node colors are similar to the observations or data points in the dataset. This is the good practice we can adopt from visualization perspective. One more thing, always try to keep all the yes on one side and all the no's on the other side from the best practice perspective. Don't mix them up. Let me move on to some of the advantages of classification with decision trees. So number one, decision trees are extremely fast when it comes to classifying unknown records. Number two, decision trees are comparatively easy to interpret if that decision tree is relatively smaller in size. Number three, accuracy is good and is comparable to other classification techniques like KNN, SVM, logistic regression, etc. if the dataset chosen is simple. Now let's see some of the disadvantages. Number one, small tweaking or changes in the training data can lead to large changes to the decision logic. Number two, large decision trees can be difficult to interpret and may lead to confusion. Number three, decision trees are more tend to overfitting. As far as applications of decision trees are concerned, here are some of them. Number one, it can be used to classify galaxies, hence it has its usage in astronomy. Number two, it has its usage in physics to detect the particles. Number three, in retail industry, it can be used to know about a customer satisfaction against any product or services. So folks, this is it for this video. In the next upcoming videos, I will cover various other classification algorithms like naive Bayes, random forest for classification. So stay tuned. Now here is today's question. What are some of the most popular decision tree algorithms? Please post your answers, comments in the comment section given below so that I can get a chance to incorporate your feedback. You can also post your technical questions in the comment section and I will try to answer the same. If you are watching this video and you are not already a subscriber to our channel, consider clicking that little subscribe button. In case you have already subscribed, then click on the bell icon to receive the notifications whenever I will release a new video. So thanks for hanging out with me guys. I will be covering next topic in the upcoming videos, so keep on watching. Thank you.